So today I'm going to teach about how to represent a complex number in the polar form when A and B, that is the real and imaginary parts, have positive negative signs. That is, if the complex number is of the form A plus IB, that is both of them are positive, then the modulus of the complex number is A square plus B square, and the argument is tan inverse of B by A. That is, theta will be tan inverse of B by A and R will be root of A square plus B square. Whereas if the complex number is of the form A minus IB, not plus, A minus IB, that is, the imaginary part is negative and the real part is positive. Of course, we know that the real part will be equated to R cos theta and the imaginary part will be equated to R sin theta. The imaginary part carrying a negative sign will mean that I will have to take the angle to be negative. That is, minus tan inverse of B by A. Whatever angle I am going to get for this, if it had been positive, that will take a negative sign. This will do that, taking a negative sign will do, because we know that sine of minus theta is minus sine theta, that is sine is an odd function. The modulus doesn't change, it is going to be A square plus B square only. Whereas if it is of the form minus A plus IB, in the sense the real part is negative and the imaginary part is positive, the modulus is not going to change. It is going to be the same A square plus B square. Whereas for the angle, I have to take it as pi minus tan inverse of B by A, because cos has to be negative, but sine has to be positive. In which quadrant is cos negative and sine positive? We know that in the second quadrant, cos is negative and sine is positive, and angles in the second quadrant are represented as pi minus theta. Moreover, also remember that putting a negative sign will not help, since cos of minus theta is only cos theta, cos being an even function. And coming to the last case of minus A minus IB, that is both of them are negative, the real part and the imaginary part of negative, and the modulus is not going to change the same. Whereas for the theta, we are supposed to take it as minus of pi minus tan inverse of B by A, or in short, minus pi minus theta. Okay, now I'm going to explain how this helps in getting a negative sign for both. Sine of minus of pi minus theta equal to minus sine of pi minus theta, because sine is an odd function, but sine of pi minus theta is only sine theta positive, since it is in the second quadrant. Therefore, this gives you minus sine theta. Whereas for cos, it is, let me take a bracket here. For cos, it is minus of pi minus theta within bracket, but that is only cos of pi minus theta, because cos is an even function. But pi minus theta will mean that the angle is in the second quadrant. In the second quadrant, we know that cos is negative, so I will get a negative answer for the real part as well. Therefore, by taking the angle as minus of pi minus tan inverse of B by A, we will be able to achieve a negative sign both for the real part and the imaginary part.